We're going to start by going over the heat diagram. So this should be pretty easy. We're going to draw our pot of boiling water, okay? And then we're going to draw our potato in there. And hopefully you guys drew arrows going from the water into the potato to signify energy goes into the potato. Okay, pretty simple, right? All right, so today we're going to be talking about energy again, but it's going to be a little bit different from the math that we've been doing. So I want you guys to jot this down in your notes. Because we're going to make a distinction here. So when we are talking about chemical reactions, and we talk about the energy that has to do with chemical reactions, we use the delta H variable, right? We're looking for delta H, and then it's always going to be some kind of number, and then we label it Kj. This is what we've been doing, and this is going to be the first part of your exam. The first type of question is going to be the delta H stuff, the stoichiometry that we've been doing so far. All right, now, today we're not going to be looking at chemical reactions. For this final topic, we're going to be talking about the energy, okay, just between objects. Yes. Okay, so we're not talking about chemical reactions. We're not mixing chemicals, and they're not going to react together. This time, we're just going to be talking about energy going from one object to another. Okay? The energy between objects, instead of using the delta H symbol, we're going to be using the symbol Q. Okay, so just keep that in mind. Q is going to be how we symbolize heat, so the energy going between objects. Okay, so for chemical reactions, we use delta H. For what we're talking about today, we're going to be using the symbol Q. Okay. And we're also going to have a number for this as well. So delta H had a number in Kj. This time we're going to have a number, but the unit of measurement we're going to use is joules. It's similar to kilojoules. It's just a smaller unit of measurement. Okay? So just keep that in mind. We are not using delta H today. We're using Q to talk about heat, and it's going to be a number and then joules behind it. All right, so let's talk about something, the phenomenon behind what we're going to talk about today. So you guys don't need to write this down, but we all know that if you put energy into an object, the temperature of that object goes up, right? So when we're talking about our heat diagram, if you put a potato in the boiling water, the potato absorbs energy, and the potato's temperature goes up as well, okay? Now, the thing that we're going to be talking about today is something called specific heat, and I want you guys to write this down. Specific heat, the symbol for specific heat is the letter C, and this is the definition of specific heat. I want you guys to write it down on your notes, and I'll explain just kind of in easy terms what specific heat is. But write down the definition, and just know that specific heat is symbolized by the letter C. Okay, so we're familiar in everyday life that different objects, they heat up at different speeds, right? So if you're in the kitchen and trying to cook something, if you notice the pan, right, that's made out of metal, it always heats up a lot faster than if you have like water inside of it, right? And the reason why is because of this thing right here. It's because specific heat. Different objects in the universe have a different specific heat, which basically means every substance heats up at a different rate. Okay, and that's what specific heat is. So metals, they heat up faster, and water heats up slower. It's because they have a different specific heat. So you guys don't need to memorize this, but you will have to be comfortable using this kind of table. So if you guys look right here, we got different chemicals, right? And if you guys look, they have a different number next to it, right? The bigger the number, the harder it is for it to heat up. It needs more energy in order to heat up. So the number represents how much energy you need to heat up a specific substance. Okay, so if you guys notice, metals like aluminum and iron, they have pretty low specific heats, which means they heat up a lot easier than things like nitrogen gas, which requires more energy. Okay, so real quick, just to see if you guys understand the concept, on your paper, I want you guys to write the number 2, and I want you guys to just look at this table and just write down real quick, what do you think is going to heat up faster, a block of aluminum or a block of iron? Okay, so take about 30 seconds, write it down on your paper, and just write a quick explanation. Why do you think your choice is going to heat up or is going to require more energy to heat up? Which one heats up slower? Take about 30 seconds to do that. Check with your neighbor just to make sure that you guys both understand, and we'll go over it in about 30 seconds. Alrighty, guys, so let's take a look at our table. we're comparing aluminum and iron. So we're looking at these two right here. Okay, so if you guys take a look, remember, specific heat is how much energy you need to heat up that object. So the bigger the number, the harder it is for you to heat it up. And so your answer here is actually going to be aluminum. And the reason why is because it has a higher specific heat, or C value, than iron. Okay, so the bigger the value of specific heat, the more energy you need to heat it up. Okay. Okay, so that's pretty much the concept. We're going to get into the actual math portion of it, but do you guys have any questions?
No, sir.
Okay. All right, so this is going to be the last formula that we learn for this class. I'm getting a little sad knowing I can't lecture to you guys anymore. It's the end of the year. Okay, but I want you guys to take a minute and copy this down. I'm going to break down this formula for you. I know it looks kind of complicated, right? There's big letters, small letters, but it's a pretty easy equation. You just kind of plug and chug. So copy this down on your paper, and then make sure you leave a little space because I'm going to be telling you guys what all of these variables stand for. All right, so let's start from the left. Okay, so this Q, we just talked about this. This is referring to the heat or the energy that is moving. And the unit of measurement for Q is going to be joules or J. Okay, so if you're asked to find heat, you would get a number, and then you would put joules behind it. Okay, we're going to skip C for right now, but let's go to M. M is going to be mass. And as you guys know, we always measure mass in terms of grams. All right, let's move on to this right here. In the parentheses, we have TF and TI. So the TF, it stands for the final temperature. Okay, so whatever temperature your object ends up at, once you put energy into it, that's your TF. And we measure it with degrees Celsius. Okay, I know that in our lives we use Fahrenheit, but chemistry is worldwide and most people use Celsius, and so we're going to be using Celsius for the math.
It's like the Europeans that use Celsius?
Everybody except us.
For us.
Yep.
Why?
Because we're the best. All right, and then the TI is the initial temperature. So this is your starting temperature of your object. And same thing, we use degrees Celsius. What's up?
We only use...
Okay, guys, let's talk about the one that we didn't talk about, the new one, C. So C is specific heat. Okay, and this is the amount of energy you need in order to heat up an object, right? So every single substance is going to have its own specific heat. You don't need to memorize it, okay? You just need to know how to calculate it, and we'll talk a little bit more about that later. But it's going to be a number, same thing as all of these other things, but the unit of measurement is a little bit weird. Okay, it's going to be joules divided by grams times degrees Celsius. Okay, so the unit of measurement is joules divided by grams times degrees Celsius. I put it in blue so that you can tell it apart from the other ones.
What's the difference?
Okay, yeah, so all you do is plug it in. So let's look at the problem, and I really recommend going through the problem because it's a little intimidating to read this and just kind of try to decipher everything. Let's write it down. Let's pull out the numbers and let's label it with each variable that we have. So it says that it takes 209 joules. You see 209 joules. We know automatically joules is heat, so that's going to be Q. So we're going to say Q is 209 joules. And if we move on, it says to increase the temperature of 50 grams of water. So we see grams. We should know automatically that that is mass. So M is 50 grams. Okay. And then moving on, it says from 5 degrees Celsius to 6 degrees Celsius. So these are obviously correlated to temperature. So we know that we need to have an initial temperature and a final temperature, right? So if we just read the question, it says we go from 5 to 6. That means we end up at 6. So that means 5 will be our starting temperature, and 6 will be our ending temperature.
Did you say that again, like why 5 is first?
Yeah, because it goes from 5 to 6.
Oh.
Yeah. And the question is asking, calculate the specific heat. So that means we are looking for C. Okay, so we have all these variables out, and let's be honest, this is a lot easier to decipher than trying to read this little blurb over and over again to get our information.
Is that all it is that we're doing?
Yep, and then we're just plugging and chugging.
There's no like. Oh, that's easy.
Okay, so let's plug in our numbers. So this is our equation. Let's plug in what we got. So Q is 209 joules. So 209 joules equals, we're looking for C, so we're going to leave that alone. M is 50 grams. And then inside the last parentheses, we have TF, which is 6 degrees minus 5 degrees. And from there, it's just regular algebra. You guys should be familiar with this. All you're doing is you're solving for the missing variable, which is C. Okay, so let's go over the math. Make sure that you guys are doing your algebra correctly. So you're looking for C, and if you guys notice on the right side of the equation, everything is being multiplied, right? So to move it to the other side, we have to divide it. So let's go step by step. So 209 joules divided by 50 grams. So on the bottom of this fraction right here, we're going to have 50 grams. And that's how you get rid of the 50 right here. Okay, we have 6 minus 5, so we can do that in our heads, right? That's 1. And we want to move that to the other side, so we're going to have 1 degree Celsius on the bottom. And that's how you can isolate specific heat, or C.
Oh, that's okay.
It's almost like solving for X. You could think of it that way. Okay, so you plug this into your calculator. Remember, everything on top divided by what's on the bottom. Okay, so 209 is on top, divided by 50 on the bottom. There's also a 1 on the bottom, so you divide by 1 as well. And if you plug that into your calculator, that is what you're going to get. And you should get 4.18. And then the unit of measurement, again, we have to label our numbers, is going to be joules divided by grams degrees Celsius. And if that's a little hard to remember, if you guys take a look at this right here, where we moved everything over, you'll see that it's joules over grams over degrees Celsius. So that kind of correlates right here. So I'm going to show you guys a different way to solve this than the last time. If you liked the previous method, though, you can keep using it. I just want to show you another way to solve it. That way, if you didn't like the previous one, you have another option. So what you could do is what we did last time, just plug in the numbers that we got, but that's a lot of writing. So in AP Chem, the way that we do it is we first rearrange the equation. So if you want to do it this way, it makes more sense, you can. If this doesn't make sense, just ignore me for the next minute. Okay, but we're looking for specific heat, so we're looking for C, right? So we want to isolate C. So what we can do is we can rewrite this equation with the C isolated. So just move everything to the other side. So Q divided by M, and then you can also move the parentheses TF minus TI, and that's going to be C. Okay, so if this method makes sense to you, just rearranging the equation first, you can do it that way. If this was confusing, then you don't have to do it this way.
Wait, that's a whole other way to do the whole problem.
It's another way to arrange it so that you can plug in the numbers and the calculations look easier. This is the way I do it. It's up to you. Okay, so we're just going to plug in our numbers now. Same thing as before. Q is 1086.75. Okay, and that's going to be joules. Divided by mass, which is 15.75 grams. And then you're going to have TF, which is 175 degrees Celsius minus 25 degrees Celsius. And you can solve from there. Okay, so let's solve it.
Do you divide?
So what we're going to do first is let's simplify inside right here. 175 minus 125 is going to be 150 degrees Celsius. So I'm just going to rewrite that here, but this is 150 degrees Celsius. Because this is going to be our change in temperature, right? This is how the temperature changes. All right, for the math, again, top divided by bottom. You're going to do 1086.75 divided by 15.75 divided by 150. Okay? Now, if you multiplied, you're doing your order of operations incorrectly. Okay, if you multiplied, what you would have to do is you would have to do 1086.75 divided by, and in the parentheses, you have to do 15.75 times 150. And so you have to do the parentheses first. Okay? So again, whatever method works best for you, but I always recommend just divide it. It just makes your life a little bit easier. Okay, so 1086.75 divided by 15.75. divided by 150, you should get 0.46.
Yeah, I told you.
Okay, so no matter what method you did it, as long as your math is correct, you should get 0.46.
When you write it, it looks like
Okay, so we have our labels. So we got 10 grams. Grams is obviously mass. The temperature substance goes up 0.5 degrees Celsius. So here, it doesn't tell you the starting and ending temperature, but whenever you do final minus initial, that's how much it changed, right? So inside this parentheses, it tells you the temperature change, which is 0.5 degrees Celsius. And then the Q is 0.7 joules, and which means we're obviously looking for C here. Okay, so I'm going to rearrange this equation. So C is equal to Q divided by M, and then the change in temperature. So from there, we just plug and chug. We put 0.7 joules on top. We got 10 grams on the bottom. The change in temperature is 0.5 degrees Celsius. And if you solve for that, you should get 0.14. And if you look, that means that our missing substance is going to be mercury, Hg.